Hi and welcome to my maths class. Today we're doing a revision of all the grade 10 deductions in graphs. Now when we're doing deductions is usually a lot of your previous knowledge put together. Like number one, we'll do simultaneous equations. Now when would we do simultaneous equations? You do simultaneous equations when two graphs cut. So if they want the points where the two graphs cut, then we would do simultaneous equations. It could be any two graphs. It could be an exponential and a parabola. It could be a hyperbola and exponential. The norm for grade 10, however, is a straight line and a parabola. So usually in grade 10, you will find a straight line and a parabola. The next thing you know about deductions is where they will ask you lengths. Now if we are doing lengths that are vertical, then we're going to say the top value of the y minus the bottom value of the y. And that would give us the length. If I want a length that is horizontal, then I'm going to take the high value of the x minus the low value of the x. Now how do we get the x and y values? If I am given an x value, when you are given an x value, you substitute and then you will get the y. And likewise, if you are given y and you need x, then you will substitute and then you would get x. Usually at this level, when we are getting x, you usually have to do a bit of solve for x. Then what they ask you in other graphs is they would ask you the equation of asymptotes. Now what the equation of the asymptote would be is that y would equal to a value or x would equal to a value depending on how the asymptote is running. If the asymptote is running this way, then it is a y is equal to. But if the asymptote is running this way, then it is an x is equal to. So those are other questions that they would ask you. After that, they would ask you questions like get the equations of graphs. But in order to do that, you can go to our previous summary where we discuss getting the equations of graphs. Now let us take an example. If you look at this graph, they give us two graphs. F of x is equal to 3x squared minus 4x. Now we know this is a parabola equation, which means that I'm talking of the parabola is 3x squared minus 4. So f of x is equal to 3x squared minus 4. G of x. G of x is a straight line. You can see it's y is equal to mx plus c. So g of x is equal to 3x plus 2, which is in reference to this specific line. So this would be our g of x. Now what kind of equations can they ask you, or what kind of deductions can they ask you from this graph? If they give you the equations and they tell you calculate the points of E and F, so they want us to get the coordinates of these points. What do we do? If you look, the coordinates of F and E are exactly where the two graphs cut. And when two graphs cut, what do? Simultaneous equations. So what we're going to do is we're going to do simultaneous equations for f of x and g of x. What we have is y is equal to 3x squared minus 4. And then we've got y is equal to 3x plus 2. Now to do simultaneous equations, we're going to simply substitute this in place of y. Now if you are not familiar with your simultaneous equations, you need to go back to solve for x and understand that section before you continue with this section. Now we're going to have 3x plus 2, which we put in this y, is equal to 3x squared minus 4. Now you bring everything to one side, so we've got 3x squared minus 3x minus 2 minus 4 is equal to 0. If you are not familiar with what I'm doing, please go back do your solve for x and learn this work before you continue. You cannot do deductions if you do not know how to factorize and solve for x. We have x is equal to 2 and x is equal to minus 1. But this is not the coordinate. If you look at the graph, this is simply the x values. But when they want a coordinate, they want both. They want x and y. So how do you get it? Knowing your simultaneous equations, you know in order to get your y, you can go back to any of the originals. So we can say y is equal to 3x plus 2. So we have y is equal to 8, and then we do it again. Y is equal to 3 times minus 1 plus 2, which gives us minus 1. So what is our coordinate? Our coordinates are 2 and 8, and then it is minus 1 and minus 1. Which one is which? Now we need to decide. F is going to be 2 and 8. And then E is going to be minus 1 and minus 1. Now many times if you looked at the drawing, you can see that our coordinates are exactly what we worked out. But in the exams, they might not give you this labeling. Also, they will tell you show all calculations. So if you simply look at the drawing and give me the coordinate, you'll get maybe 2 marks. But the question is worth 6 or 8 marks. So remember, you can't get away without showing the calculation. Now let's look at the next question. They say, calculate the length of AB if x is equal to 1. They want the length of AB if x is equal to 1. So they're telling us that x at this point is equal to 1. Now look at our deductions. If I want the length of a line that is vertical, I'm going to say the top y value minus the bottom y value. But if you look at the graph, I have that the x is 1. And at the bottom by B, I have that the x is 1. But I don't have the y values, and that is what I need. Now in order to get y, when we are given x, what do? We substitute, and that's how we will get y. So what are they saying? What they mean is, you've got x is 1. A is on which line? It is on the straight line. So in order to get the y value, I'm going to say g of 1, which means I'm substituting x as 1, is equal to 3 times 1 plus 2, which gives me 5. That means at A, my coordinates is 1 and 5. Then I want to do the same thing with f of x. Now why am I taking f of x? Because B is on the parabola. So I'm going to have f of 1 is equal to 3 into 1 squared minus 4. And that gives me minus 1. So what is my coordinate at B? I've got 1 and minus 1. Now, we were given the x value, we substituted, and we got the y value. But now when I want the length, I take the top y value minus the bottom y value. So, the top y value is 5, and the bottom y value is minus 1. But look at what we're saying. It is top of the y minus the bottom of the y. What is the top of the y? 5 minus. What is the bottom of the y? The bottom of the y is minus 1. Be careful with your signs. There are 2 minus signs. So what does it become? 5 plus 1, which is equal to 6. So when they say calculate the length of AB if x is equal to 1, then this answer is top minus bottom, which is 6. So the length of AB is equal to 6. Now they say calculate CD. Where is C and where is D? C and D. again, if you look, it is again a vertical length, which means the top y minus the bottom y. What is the top y? The top y is 2. Minus, what is the bottom length? Minus 4. Be careful with your sign. So we've got 2 plus 4, which is equal to 6. The length of CD is equal to 6. Okay, let us look at a different drawing now. If you look, these graphs tend to have asymptotes. When you look at the deductions, you will see that asymptotes is a very common form of deductions. They like to ask you, what is the equation of the asymptote? So, when you know the asymptotes, you can get the equations. The asymptotes is usually found in a hyperbola and exponential graph. Let us look at this graph. Now, if you look at this, f of x is equal to 2 to the power of x minus 4. That is an exponential graph. Without thinking, you should know from previous knowledge that this is an asymptote. Even though it is not drawn here, you can see there is no line drawn, but in the equation they tell you, listen, there's an asymptote. If you look here, there's another asymptote. Can you see? The g of x, which is the hyperbola, we're now looking at the blue graph, there is another asymptote. How are these asymptotes running? Can you see? They are running horizontal. Now look at the deductions. When we have horizontal asymptotes, when our asymptotes are horizontal, then I have a y is equal to. So if you see, you already know, hey, I'm going to have two asymptotes. One is going to be y is equal to minus 4. One is going to be y is equal to 1. Now let us go to the type of questions that they ask you. They'll tell you, look at the first question. Give the equation of the asymptotes. So we know the equation of the asymptotes is, for the one we have y is equal to minus 4, and for the other one we have y is equal to 1. But when you look at the hyperbola has another asymptote which is not always so clear, and it is this specific line. When we have an asymptote that is running vertically, then we have x is equal to. Now this vertical line, x is equal to what? If you look, they are talking of this specific spot. And at this specific spot, x is 0. So what is the other asymptote there? The other asymptote is that x is equal to 0. When they give you this, you must look at the mark allocation. The norm is that this mark allocation would have been 3. 1 for each asymptote. Now, you see 2 easily, but in the hyperbola, remember in grade 10, there are always 2. 1 is always x is equal to 0. Only in grade 10, in grade 11 it will change. Then they say calculate the length of CD. Now let us look where C and where D is. Calculate the length of CD. Now we know if we are working with lengths that are this way, we need the y values. What do we have? We have the x value. Once we have the x value, how do we get the y value? You substitute into the original and you get y. So we're going to take the two equations. F of x, so it's going to be 2 to the power of 1 minus 4, which gives me minus 2. And then we've got g of x, substituting the x value in order to get the y value. Now once we have that, what do? We say top minus bottom. So we know this coordinate is 1 and 3, and D's coordinate is 1 and minus 2. I'm only interested in the y values. So I have 3 minus minus 2, which is equal to 5. So the length of CD is equal to 5 units. Now they tell you calculate the length of AB. So we want the length of AB. If we look, AB is running horizontally. When we are doing a horizontal length, look, I'm talking of my x values, and I'm going to say a high x minus the low x. Now, what is the high x? The high x is actually 2. So, AB is going to be the high x, which is 2, minus the low x, which is minus 2. And that gives me 4. Because remember, 2 and then a minus and a minus give me a plus. So we've got AB is equal to 4. So now we have that AB is equal to 4 units. Now look at what they are doing in the next equation. They are saying give the equation of f of x plus 4. Now what they're doing is they're taking the original f of x. If you take our original f of x, our original f of x is equal to 2 to the power of x minus 4. Then, to this f of x, they are adding 4. So if you look now, I've got f of x plus 4, and here I've got f of x plus 4. But the rule for maths is that what you do on one side, you have to do on the other side. So I'm going to also add a 4 on the right hand side. That will give me 2 to the power of x. So f of x plus 4 is going to equal to 2 to the power of x. Let's take another one. Now they're telling us do g of x minus 1. So I know g of x is equal to 2 over x plus 1. What are they asking me to do? They're asking me to subtract 1. So from g of x I'm subtracting 1. But what I do on one side, I will do on the other side. So what do we have? We have that g of x minus 1 is equal to 2 over x. Now, look at the next question. When you took question 4 and question 5, they were working outside the function. They weren't changing x. So we simply took it and we added, or we did the adjustment. But now they are doing something different. What are they doing? They are giving us x. The question like this is exactly like this. I give you x, so I substitute and I get y. It is very similar to that. They are just writing it different. So what they're saying is that we're going to start with g of x. G of x is equal to 2 over x plus 1. Then they are saying in place of x, I'm going to put a minus 1. So in place of x, I'm putting a minus 1. And then I'm going to have my same sum, but in place of x, I'm putting a minus 1. So what do I have? My final answer is g of minus 1 is equal to minus 1. And they are telling us to call this a. So I'm simply going to say a is equal to minus 1. Now let's look at the last one. The axis of symmetry. What does axis of symmetry mean? Axis of symmetry means that if I had to fold the graph in half, then the two graphs that are drawn would fit into each other. But look at what they are talking of. They are talking of g of x. Okay, so let us take g of x. Which graph is g of x? G of x is the hyperbola. Now what happens is, if I can fold this graph such that this blue line fits onto this one, then I have got an axis of symmetry. Now, one way that I can do it is, my axis of symmetry is that I fold it on this dotted line. Now, that means that this blue line will fit onto this blue line. But there's another axis of symmetry. If I go this way, then this part here would fit onto this part. So if I fold the paper, this part would fit onto this part, and this part here would fit onto this part. So there are two lines of axis of symmetry. You can see that axes of symmetry are straight lines. Now to get the equation of a straight line, you need a gradient and you need a point. If you are not familiar with how to get the equation of a straight line, you have to go over your grade 9 work, Or you also can go over your analytical geometry, because to get the equation of a straight line are in both these sections. It's revision of grade 9 and you're going to find it in your analytical geometry for grade 10. Now, how do we know the m's? The m's in axis of symmetry are exactly the same. This one is a negative gradient, so it's always -1. And this one here is a positive gradient, so it's always +1. So we have the gradients. Now how do we get the point? The point is created by the asymptote. Now that coordinate is 0 and 1. So if I have my gradients, we have our gradients, m is equal to 1 and m is equal to -1. Then we have our coordinate. Our coordinate is the same for both of them, which is 0 and 1. So I have my coordinate 0 and 1 and I have my coordinate 0 and 1. Now to get the equation of the line, we can say y is equal to mx plus c. This is one method. So I got my m is 1 and then I simply substitute my coordinate and that would give me that c is equal to 1. So how do I rewrite it? Y is equal to 1x plus 1. The second method you can do, remember this is a different equation, I'm just showing you two different methods of getting the equation of a straight line. Y minus y1 is equal to m x minus x1. So I have y and then my x1 and y1 is my coordinates. My m is given to me. Then you get rid of the brackets. So I've got y is equal to minus x plus 1. So our two equations of axis of symmetry are y is equal to 1x plus 1 or y is equal to minus x plus 1. Thank you for watching.